Hello everyone, this is my presentation for stacks on ComSci 123 by Michael Vincent Dosado. So today we are going to discuss what is a stack, its implementation, and a problem and solution. So what is a stack? So it's not this one because this is stock, like stock exchange. It's also not this one because this is stuck in the wall. This could be a stack. The snacks. This we'll see later. So stack is this one, small representation. So it is a linear data structure and follows the last in, first out principle, or the LIFO principle. Or you could also call it the first in, last out principle, but the LIFO is much better because you focus at the top. So you insert, remove, and access items or data only at one end, which is at the top. So you use the LIFO principle when removing items. So it's really more of like the stacks, lays, stacks, snacks right here. So it really follows that procedure. So what is a stack? So for a more clear definition, so stack is an object, or more specifically an abstract data structure that allows the following operations. So you push. So the push here adds an element to the top of the stack, which is right here. When you push, you add an element at the top. And when you do the pop method, you remove an element also at the top of a stack. So the last in was also the first one to go out. And the isEmpty method checks if the stack is empty. So right here it will be false because we have a data element right here, elements right here. Is full, we'll check if the stack is full. So it could be true here because it is almost full, or false because it is adding another data element. So peek, the method peek, or you could also call it a stop, it gets the value of the top element without removing it. So it just shows you what the element is at the very top of the stack. So as a more clear representation of what the methods were. So when you push at the top of the stack. So it was the first one to go in. So you push one here. Then next you already had a one here. Then you push two. Here's this one. Then you push three. So three is now at the top of the stack. When you pop three, the top part is also the one being removed. So the last was to go in was 3, then it was also the first to go out when it was popped. Then when you pick 2, you just look at what the top item is. So it just shows you 2. Then you pop 2, remove, then you pop 1. Then you're back with an empty stack. So is empty is true here and is full is false. So applications of the stack data structure is to reverse a word. So just like when you type a letter, type a word, when you apply a stack method to a word, when you try to reverse a word, you type in a word, then whichever the first letter was typed, then it will be also the last letter to come out. So the last letter that was typed in will also be the first letter to show when you put them in reverse order. So it also does the same in compilers. So it uses somehow order of precedence to rank how it would process. So in browsers, it's the same. When you search in the internet, say you went to YouTube, then you went to Y8 Games, then you went to freev.com. So it follows a stack order. So the first one that you enter was YouTube. It will be at the bottom of the stack, and followed by Y8 Games, then and then Freev.com, which was the last site that you opened. So other application of the stacks is, as we mentioned, the page visit history in a web browser, the undo sequence in a text editor or any software that you use. Let's say in Microsoft Word, when you do undo sequence, the last thing that you did will be the first one to be undone. Alright, so every process in a computer system has a user stack to maintain its context. So it uses a stack so that it will keep track of what you did recently on the process it does. So the subroutine method call structure is maintained in a LIFO basis. So when you do, let's say, recursion, the first function that was called will also be the last function that will finish its job, and the recursion last function it called will be also the first one to finish. Then its return item will give back to the next earlier function call that occurred until it gets back to the first one. So it follows the stack method and auxiliary data structure for algorithms. So we have three commonly used implementations: the simple array-based implementation, the dynamic array-based implementation, the linked list implementation. So first here we have the simple array-based implementation, which is the basic implementation of stacks. So in our representation right here, it's just a simple way of making stacks. You add elements from left to right. It just always starts at index 0. Then when you so in its implementation, you push an item at the first empty slot. So let's say our first empty slot here was 0. When you pop an item, it will also pop the last array item that you entered. The top item is the last array item. Then after you do all these methods, you update the size property. So in the dynamic array-based implementation, there are two strategies for a growable stack. First is the tight strategy and the growth strategy. So in the tight strategy, what it does is just adds a constant number to the size of the stack, while in the growth strategy, it doubles the size. So let's say you had a stack with four items, and when you use a tight strategy, if let's say the constant was 2, then it will just add 2 more boxes or cells to your size. So if it was 4, then using a tight strategy it will be 6 now. But if it was a growth strategy, then it will double the size. So if it was 4, then when you expand, it will become 8. The size will now become 8. So just right here. So this one right here is a dynamic array dynamic. It follows a growth strategy. So 1, 2, 3, 4, 5. It was 5 here. Then when it was expanded, then it also expanded 5 more items. The current size was doubled. Right. In the linked list based implementation, using the linked list, it also follows the same. Push A. It's just that the top part of the stack is also the top node or the
tail node of the stack, and the first node that was pushed is what you call the head node.
So every node is connected to the next node. So it's just the same right here. So the first node is connected, since it was the first one to be placed, so it's connected to the second one to be pushed, the third one, and the last one. So the last one here is our top node. Alright, so for our little problem solution, let's say you have 5 flavors of stacks. Potato crisps, you have sour cream, the green one, cheese, original, barbecue, and salt and vinegar. So what you wanted to do is you get each one of each flavor and you put them in another stacks container. You take, let's say, one piece of every flavor and you put it in another stacks container. And you wanted that barbecue to be at the bottom of the stack, to be followed by original flavor, the cheese, the salt and vinegar, and the sour cream at the top. So how would you do that? So as we know about stacks, first we pushed barbecue, we wanted to be at the bottom. So this is our top item. Then it was followed by original flavor, which is, and then you update, this is now the top. Then the next was cheese, then you also update, now this is now our top. Then you follow the salt and vinegar, so this is now our new top. And finally you have the sour cream at that top. But then you put your stacks in the fridge, and on the next day you wanted to eat everything except the barbecue flavored potato crisp. So how would you do that? So we pop the sour cream flavor chip. So it is now updated. Our top is now updated. It is now the salt and vinegar one. The next is now topped. Then you when you pop the chip, and the top and will be updated. So our top node right here will be cheese. Then you pop it again. It will now become the original flavor will now be the top one. Then you pop it again as you eat it. Then it is now the, so you are left now with the barbecue flavored chip at the bottom, and this is now our top, the only item left in your stack. Alright, so I hope you understood a few concepts of stacks and its implementations by our usual representations and its applications and our example problem right here. So thank you very much for listening and have a good day.